You feel great or you feel pleased that you get something from your past year. 我们过去的几年，像我这个年纪，你就会去感受。You will feel something, whether your life is active or is passive. 你是很被动的，还是你是很活跃的？ Which is very strongly related to your achievement. Okay, to my age, I cannot change anything. I just review my past. Is wrong or right? Because your achievement just out of this level. Maybe level is high, maybe it's low. All right. Okay. So all your assumption, everything you do. Every day is used to determine your future achievement. Believe me. Right. In order to just get the master degree, it's a must. You cannot wear the mask for all your life. All your achievement is related to your brain, whether your brain is filled with knowledge or just something, nothing. So, you write your homework, please do by yourself. You can discuss with each other. I just review your homework. I just look at whether you you do your homework very hard, or it's just very random. I don't have the definite solution. Like I study in the United States. Every homework no definite solution. The solution may be different. You can think about it. You can propose your idea for me. That's very good. Not just get the grade, I got the master, I get the PhD. So what? This is stretch term. 这一项 UA、UB, if your profile is look like this one, you have your low surface. Originally it's UB, but it becomes the variable. 你会发现你的速度从这边慢慢变小了。That's because originally you are fixed value, but you have elastic opacity deformation. Allow your velocity, your flow velocity at the bottom surface or at the low surface to be changeable. Okay, from the high to low or from low to high. If the change is UB is changed like this way, and then we assume that the upper surface with the zero velocity, 上面这个面如果是0的速度，底下原来的速度，因为你有变形以后 ，change from high value to the low value. If like this way, you can create a particle pressure. But your pressure profile is look like this one. Okay, your pressure profile is look like this one. Then your particle pressure is created if your UB is changed from high value to low value. So in this case, look at this term. UA equal to 0. UB changing with x is negative or positive? Here, 它是正值还是负值？From large to small, partial UB, partial x is negative or positive? Give me answer. 啊？正值还是负值？正值啊。这个大，这个小，那这个呢 ？partial UB, partial x， 正值还是负值？If you cannot identify this value is positive or negative value, I will say you are mathematical. It's not pass. Okay. not okay. Negative, right? Partial T, partial X means the change of the U in X direction. It becomes small and small. It means this value is negative, right? So U and UB are positive value. Here, H is positive value. Rho, of course, its density is positive value. It is positive or negative value. It depends on this partial UV, partial X is positive or negative. You find that from large to small, then we create the positive pressure. Mean this value is positive or negative. Repeat. 下一个正来物负值 So if this term is negative, you can create a positive pressure. Write down. Okay. Last one. This term is negative. It also allow you to create a positive pressure. 这个密度随着 x 方向减少的时候，也会产生正压。所以这一项，因为 U A U B 都是怎么样正的方向，所以这项你必须要负值，才能够产生正压。而 this term should be negative value, then you can create a positive pressure. Please, you keep in mind that you needed some area created the higher positive pressure. That is because you need a lubrication, not just put the oil. Oil is not the key issue, not a key factor. The key factor is that in the flow fin, you can create the positive pressure as large as possible. This idea is very, very important because you work in the outside. Most people that put the oil, you can obtain the high efficient lubrication. I would say no, because you don't create the high pressure, high part pressure. So this term should be negative, and then this term should be negative, right? This we call the stretch mechanism. Okay. This case is occur when you have a high pressure and allow some area have elastic deformation. Okay, so here, right? This term we call the physical wedge term, which is just two surfaces, another in parallel. 它并不平行，它有一个倾斜角，这个倾斜角4度，最多大概4-5度。So there's a lot of people make wrong. You put the installation of the flow in this direction. This is it. Then we created the pressure, positive pressure. If we put it this way, okay? 由大变小，它就有挤压的作用 ，right? There is wedge. The wedge allows the flow to be squeezed, right? If squeezed, they have a high pressure created in the flow field. If it expand from small length to the large length, and they expand, then you don't have the high pressure created in the flow field, right? So you have design look like this one. This we call the wedge effect. All the value are trying to develop the wedge effect to create the positive pressure as large as possible. Okay? Bearing always just every fail like our body, in the joint, in our eye, right? In our mouth. Every fail we have the lubrication behavior. We try to develop the high lubrication can avoid the wear and then reduce the friction. How to do it? Allow the lubrication, create high pressure. Like why we have water between the tooth, between the teeth. That's because this water allow us to separate the two teeth, and then create the very small friction to avoid the wear of your two teeth. Like why we have a tear, that's because we have a water between two moving surface, to protect your eye, protect your knock eye, right? Or we call the lubricant. And then in the machine, in every engine, with a lot of very different kind of lubrication, we need to design it. All right? So here, physical weight from here to here. Okay? Here we have two kind of like this one. Apply it again on the board. And then this UA equal to 0, and the UB is moving this way. Okay, all right? And then here, we have an X defined in this direction, or Y in this direction. In this direction, or in X direction. If we define in this direction, okay, and then our UB plus UA, if in X direction, this one, so right here. If you define your X is the right wall, right? In this case, your UB plus your UA, your UA equal to 0, right? This value is this side, on this side, so it is negative. Right? And how about this one? If you define this way, and then your configuration is like this way. One, H dx, H change with X direction, if defined in this way. What is the value? Large than 0 or small than 0. 这个值是大的，是大于0还是小于0？ This one. If we cannot understand, you'll find your undergraduate, you cannot learn much enough. This is mathematical. EHPX 大于0还是小于0？告诉我，这个越来越大还是越小？越来越大还是越小？Positive or negative？ UA plus UB smaller than 0, and DHX is larger than 0. It looks like this case. You define your X in this way, in the right wall, right? So, please tell me, UAUB times partial H, partial X. This term is positive or negative?这个值是正值还是负值？这个 UB、UA 这个加起来是负值 ，partial H、partial X 负值，两个成绩是正值还是负值？负值，所以这个值是负值，才会产生正压。写一下。 Okay. Please focus your mind on the class. Okay. Not just listen something and didn't get anything. Okay. So velocity, this term, UA plus UB is a negative value, and partial h partial x is positive. So the negative times the positive. So this value, this term, is a negative value. If it is a negative value, like the last two one, we can create a positive fraction. Okay. Now, if you change your x to be this direction, to be here, you change from the right side to the left side. You allow your x to be the positive direction, to be this direction. 你让你的 x 轴沿着这个方向来变。In here, UA plus UB, this value positive because your x is defined in this direction. 你的 x 在这个方向的话 ，UA UB is the same direction of this x. If your x is defined to be in this direction. But here, from here to here, partial h, partial x should be negative, right? From here to here is large to be small one. So partial h, partial x is less than 0. So this term together should be negative, the same as this one. So you define your x in this direction or in this direction. You have allowed this term to be negative. In this case, you can create your positive ratio like this one. Okay? All right? Look at the velocity profile. Look at this velocity profile. Tell me, 告诉我这个速度，你是从左边进去还是从右边进去？从哪个方向？你的速度分布，上面是0的速度，所以这边没有速度。底下有一个速度，我这样标的话，你的 x 方向是哪个方向？ Your x positive x direction, in this direction or in here, in this direction. Is the movement, this flow is from the left hand side to right hand side, or from the right hand side to the left hand side. Which one? 我速度的 profile 这样标示的话，哪个方向？从0的速度，这个板子表面的这个流体的速度是这个流体的速度是这个。那我问你，流体是这样走还是这样走？哪一个 ？Which one is the flow direction? If the profile is plotted like this one, which one? 应该是这个方向。哦，我发觉这个在座很多我们的同学哦。OK， 这个速度你可以看出来，它就是怎么样？你这个板子这样走移动的话，我的流体应该是这样走。Alright， 你看流体是这样走的话，你的速度的 profile 就是怎么样？靠右。这个速度是靠左的。当然，流体是从左边往右边，从右边往左边。Okay, alright. So the direction. So our x is defined here or here. Which one? Is this case or this case? In this one, x is this one. So please mark x here, not this here. It's marked here. Alright? And then you have this term value to be negative. In this case, you can create a positive ratio. I repeat again. Try to have your sum area, lubrication area, to have a positive ratio, and then this value should be as large as possible. That's the only way you have a high efficiency design. You good lubrication. Okay. Not just put the oil. Put the oil is not the key issue. You try to keep your fluid with the particle pressure. This particle pressure is high as possible. So this X should be here. So it's associated with this case. This we call the wedge. You find that the flow from right hand side to the left hand side, right? You find that the space is become small and small. 这个量越来越小。This space is changed to be the negative value. The thin thickness becomes small and small. The space becomes small and small. In this case, we call the wedge effect. All the very important things that try to have your mold and then your workpiece or your bearing to have wedge effect. If you have wedge effect, then you can create the particle pressure. 你要试着让这个 wedge pressure 满足这个 case， 不满足这个 case。In this term should be negative. Okay. Now next one, relative of the class. Understand the physical sense. All right. Not just take this course. Okay. Here we call it this normal squeeze term. Normal squeeze term is this rho times WA minus WB. If two surfaces, they have the lubricant between the two surfaces, right? If the thickness is increased, if you increase your thickness, you'll find that the space become large. You can create the thin thickness? No way. Okay. Please return to the Reynolds equation. The Reynolds equation, if P is large, how is the H? If you keep this term to be the finite value, you increase your P. How to increase your P? You have to reduce your H. Reduce your H to create a large pressure. If you increase your thin thickness, then your pressure will be low. Keep write down. Okay? Write down. Very important. Not just give the large space, allow the lubricant entity. No way. Impossible to create the particle pressure. The lubrication is allow your thin thickness, increase your pressure, become low. Your thin thickness is low, then your pressure become high. Okay. So they are opposite. They combine together should be the modular value. 它们的值两个乘积薄膜增加，薄膜厚度增加，你的压力一定掉下来。薄膜的压力这个减少，你的厚度一定增加，就是说你厚度增加，你的薄膜就会压力就掉下来。不是你去开一个孔，说我多一点油让它进去，那是没有意义的。所以 it doesn't make any sense that create the thin thickness, then allow the fluid film enter the space. No way, you cannot create any particle pressure. Because if the thin thickness is too large, then your pressure is low down to be the gel pressure. That's very, very important. Understand? So lubrication is not an easy thing. Okay. 所以这个就是我们讲到的这个physical sense. Okay, next. Here, normal squeeze. So, how to allow the squeeze turn to create the particle pressure? Allow, the upper brake move the velocity, we call the WA, in the normal direction, upward, right? The low brake also move in the upward. We assume maybe they are separate, maybe this is not always in the upward, maybe the downward. But finally, this WA minus WB, this value should be not equal, right? Should be WA minus WB should be less than 0. They have close each other. Allow the thin thickness decrease. You have to allow it to decrease. If it decrease, then the flow originally inside of the fin, they have to be squeezed out of the two sides. So the velocity will look like this one. On the right hand side, the velocity look like this profile. On the left hand side will be this way. Because these two surfaces, they are close each other. So they close each other, we call the squeeze effect.
So this term will be negative all the time?
Hmm?
So this term will be negative all the time?
Yeah.
But I don't see what...
It just WA is just this spread, up spread.
But it's just this part.
Right. And then you have an impact force.
And B, it will be this one to this one.
The upper one, we have origin this
Yes.
velocity. Then the lower one, WB, right?
They go to the top of A.
Yeah.
Okay.
Okay. So WB also have its velocity, right? Well, I show you the upper wall. We care it is upper wall or negative wall. But if WA minus WB, it is a possible value less than 1. You mean the thickness is decreased, alright? I don't care whether it is upward or downward, alright? If this value, these two values minus each other, then we create a negative value. You mean the fin thickness is decreased. Fin thickness decrease. If it's decrease, we call the squeeze effect. Okay. This like this one. And then we can create a positive correction. So this term also negative value. Please find out. This value should be negative value. If we needed to create the positive correction, 你如果要产生正压，这个值要负的。Okay, the last term we call the translation squeeze. Okay, let me talk about they have a solid case. The solid case is look like this one. This is the dash curve. Let me look at this equation. Let us look at this equation. They have the UA. UA is the upper plane moving surface in the horizontal. 这是 UA 是上面这个板子在水平方向的运动。Alright? Okay. Here is the partial pressure because of our x in this direction. Alright? So in this case, now partial h, partial x is here. Alright? Okay. Here, dash 1 is this case. First, this case. If this case, like this case, is like this one. This one. Here, from large to small, right? Okay, if you look like this one, we call the pitch wedge mechanism. Okay? And then just this solid curve, like this one. Okay, so solid curve, we have the profiles, look at the one. We have the solid velocity profile, like this one. Right? So the solid profiles, just like this one. And then we compare with this one. This one is this case. This case origin in this position. Now it's moving to here. Alright? Let me plot it on the board. You design your model or design your workpiece in contact with your model. That's very important because the configuration or shape of your model is totally dependent on your design is good or not. Okay? Please believe me. Okay? Your model is designed by you. You can choose the optimal design or the worst design. Okay.
I don't catch what is or why is it not
this x direction is x1 minus x2.
Yes.
If in this direction,
Yes, it will be.
this is x1 minus x2. This is x2.
Yes, I got it. But
You can use this direction.
okay, you don't change each two.
Right. Okay, you just change your x to be defined in this direction. You can change it to be this x direction.
It's because your denominator becoming negative. That's why.
Right. X1 is just in the real, and then the x2 in general we define to be the front one. Okay. All right. Understand?
So for this one, this case, it will be this one.
In this one, because we look at the velocity profile, is this direction. So flow is from this direction, from the right hand side to the left hand side. Because your flow profile, you look at that one. So your x is just in this direction. Because your UB also in this direction. Okay? So your x is should be in this direction. This is our case. Alright? Now, this is just a physical wedge case. Okay? And then here we talk about we call the translation split turn. Split turn we have two turns. One is we call the normal split and then tangential split. What is the tangential split? That means here, originally this upper plate is other disposition. 我们原来的时间的位置，这个上面这个板子是在这个位置 ，with the inclination angle, small inclination angle， 有一个倾斜角叫 theta. Now we move here, from here, we call the UA. Alright? So this point, for a unit time. 在一个单位时间里面，这个地方它会移到的这个地方。Originally it is at this position for this point. Now it is moving to this point. Alright? So it is UA times 1 because our time set to be the unit 1. So you move distance from here to here. Then any point from here move to here. This length is equal to this length, right? 所以我们单位时间是从这边平行的移过来，移过来以后，这个点就跑到这个点。那我们看这个坐标 ，at this fixed position, okay, we set this position to be the fixed one. Originally at this position, at this point, it is this point. But if this point move to here, our fin thickness is decreased. From here to here, right? Is correct? Okay? This point move to here, and then this plane move to this plane. 从这个面移动到这个面的时候，我们看这个点移动到这个点。And then your original fin thickness out here is look at this one. This is original fin thickness. Right? 原来的这个厚度。但是因为你这个面移动到这个点的时候 ，if this surface move to this position, then you find that your fin thickness become this one. 所以这个是原先的，这是后来的。所以你的这一个厚度是减少还增加？减少还增加 ？Your fin thickness decrease or increase when this plane move to here. Your fin thickness become small, so we call the split. This we call the tangential velocity. Allow your fin thickness decrease. OK? 那清楚吗？好了，写一下。 很多人在睡觉啊。OK， 这个也是这个。OK，this we call the tangential translation squeeze term. Okay. So squeeze they have two effect, two factor. One is the two surfaces close each other. Another data we have an inclination angle, a surface movement translation. Translation at distance allow the original thickness decrease. In this case, we can create a particle pressure. 这个也会产生正压。So these two squeeze terms combined together, we call the squeeze. 我们两个把它加在一起，就是 squeeze effect. Alright? Okay, understand? Okay. So after class, please review it carefully. Because in the future you want to design a lot of the mode. The mode how to design allow you create the particle ratio in your location. That's a key issue, very important issue. So, in this case, UB, UA is a particle ratio, is partial. Partial H, partial X is positive. So, UA is positive. This is also positive from here to here. Please mark here. Your X is this way. Okay, no. Okay, your UA is positive. So please mark X here. Need X, positive X at the right hand side. On the right hand side. Okay, 你的 X 在这边。Your UA is the same direction of your positive direction. So your UA is positive. Partial H, partial X from small to large. So partial H, partial X in this X direction also positive. But the positive value times positive pressure gradient, but they have the negative sign in front of these two values. Okay, so this value should be negative value in order to create the particle pressure. Okay, this direction, X. UA is in the same direction of X direction, right? Partial H, partial X from small to large. So partial H, partial X also positive pressure, right? Because you increase. Okay. If we are mathematical, okay. You are the greatest student. You have to understand every differentiation. What is the physical sense? Okay? If not, you are not so qualified. Okay. So this value should be negative to create the calculation. Yes, we call it translation. Okay? Alright. So in the future, when you design, you try, if your surface have an inclination angle, you try to have this term to be negative value. Okay? You can choose. You can choose your U direction, or you choose your fin thickness change. Either way, you can create allow this value to be negative value. So if any in the future your business to be a billion people, all right? You have thanks me, okay? You have record that your design allow you to get a lot of money, or much money. Okay, that's very important. Okay. And then the last, we call the local expansion rate, is density changing with time. Why the density will change with time? In general, it's related to the thermal behavior. They have a heat from the outside transport into the fluid field. 你的热从外面传到这个流体里面 ，allow your density decrease with time， 让你的密度随着时间一直下降。有外面的热量传过来的， your body may be operating in a high temperature environment， 你的这个轴承很可能用在很多滚压那个地方，热的要死 ，OK， 那个热量会把你的润滑油加热，一加热以后 ，your density will change with time。Okay, in this case, we have this one. So H is positive value, H is 正值。Density change with time is positive or negative? Which one? Your density decrease. Which one? Partial rho, partial t. Positive or negative? 随着时间怎么样？上升还是下降？啊？密度下降了，那 partial t, partial rho, partial t 正值还是负值 ？Tell me. 负值。So if I put the heat from the outside into the fluid field, in this case, partial rho, partial t is a negative value. H is a positive value. So in this case, this value is a negative value. So this value is a negative value, allow you to create the positive ratio. All right? Understand? So all the term in the linear equation, except the partial flow, all the term should be negative value, allow you to create a positive ratio. All right? So rigidity. Okay. So this we call the local expansion. What is expansion? Because your density allow your volume originate this volume. 你的这一个材料原来是这个体积 ，but your density becomes small, then your volume will expand, right? 你的密度减少以后，你的这一个体积会怎么样？会膨胀，会增加，因为你加了外面呢，不小心呢有热传进去。这个时候 ，partial rho, partial t is a negative value. Alright, so this is also negative value allow you create okay, this look like the switch form, right? Here, we don't change the fin thickness. Last one, we change the fin thickness. We change the fin thickness, but here, we don't change it. This fin thickness is the fixed value. We just change the density. 我们在这个地方，这个厚度没有改变，我只改变我的密度，啊，跟改变这一个厚度是不一样的。Alright， 要清楚吗？刚才这个是两个面 close each other， 两个面互相靠近的话，厚度是改变的。所以前面的 squeeze 是透过厚度的改变。So the previous one is change with your fin thickness, allow you have a squeeze effect. But here we cannot call the squeeze because we change it, not the fin thickness, it is change the density. This we call the expansion term. Okay? Alright? So all the system should be negative in order to have the particle pressure created in the flow field. 你要产生正压，一定要这些值都是负的。Okay? Right? So from this one, now we turn to allow this complicated form here, complete form, to be a compact form, to be grouped, to be related, to be the compact form. 我要把那么复杂的这些数学式子写成一个比较简单的一个数学式子。所以等一下我们的这个休息一下，把这个量写成一个更简单的一个方程式。Okay? All right. Okay. All this term very useful for your idea to have an optimal design in your work. Read it many times. and then they have the chapter, they have the table, allow you different design, will give you different efficiency, right? Like rotating in the counterclock, clockwise or counterclock， 你要让它正的方向转还是反的方向转？然后要往前还是往后？ So the mechanism design is very important. If design is like your robot, you try to your robot have a higher position， 你要很好的定位的话，这个 joint 这边的设计就变得很重要。第二个是刚性，好，所以这个很多的arm 这些东西，你要去抓取的时候，这一个 joint 这边的这一个，要是这个有震动或者是有一些刚性不行的话，你要定位门都没有。Alright, so location is very very important in many fields, in many field. Okay. So read it. Okay. So we have 10 minutes break here.